today's webinar on data management, brought to you by Better Buildings and the Smart Energy Analytics Campaign. Happy Pi Day to you all. I'm sure all of you guessed the answer to today's quiz. Pi Day, I was surprised to find that someone's worked it out to over 22, I said million? I think it's trillion digits. Typo there. But happy Pi Day. I am Elliot Crow, here to say just a few words before we jump into today's session. On the screen here, you see the fantastic team here at Lawrence Berkeley National Lab working on energy management and information systems. We have some excellent speakers lined up today, but first we'll run through some quick-fire announcements. Many of you will already know about the Smart Energy Analytics Campaign, and I would encourage the rest of you to head over to the website to find out more. We are helping facilitate adoption of EMIS and monitoring-based commissioning through technical support, networking opportunities, resources, and recognition opportunities. Right now we have 63 participating organizations covering over 4,000 buildings and over 300 million square feet. If you are an owner, please reach out to find out more, and if you are a service provider, please consider if any of your customers would benefit from participation. We recently showed up on Twitter, Facebook, and LinkedIn, and we're really hoping that provides another way for us to connect with you and for you to connect with each other. Right now in our LinkedIn group we have 34 members, and I'm really hoping we can get that up to 50 by the end of the call, so you have my permission to flip over there very quickly and get joined up. We'll see how it's going later in the call. All right, to our featured topic. Now, data management is one of the most common topics on which we get questions from building owners. Most owners are dealing with a wide variety of control systems and meter infrastructure, often with proprietary hardware and communications, and they're trying to pull it all together so they can take advantage of some great analytics tools that are out there. Each situation is unique. Each owner might have different ways they want to use their data, so there's no single right way to approach it. We're really hoping that today's presentation will help you make smart decisions when planning and implementing an approach that's going to work for you, and that's irrespective of how much of the effort you want to manage in-house versus going to a consultant. I think it's great just to have the overall structure nailed in terms of concepts and all the key pieces of the puzzle. All right, without further ado, I'll start talking about these fabulous presenters we have today. Three great speakers from LBNL and NREL, and I will introduce our first speaker here as he's pulling up his presentation. Marco Pretoni is a research scientist at LBNL. In the last 5 years, he's been involved in multiple projects aimed at developing advanced controls and analytics for commercial buildings. Recent work includes helping 3 large campuses deploy and test central data warehouses to support FDD, measurement and verification, and energy modeling and forecasting. Over to you, Marco.
Hello, everybody. Can you hear me?
Sure can, Marco.
Great, thanks. So first of all, I would like to thank this great team, Elliot, Hannah, Claire, Gwen, and Jessica for inviting me. Today I'm going to talk about data architectures for data warehouses or data storage systems and my experience and lesson learned from implementing this, helping 2 campuses implement this. So first of all, we know that this is a way of classifying EMIS systems, which is through division between whole building level and system level. I like to classify them by being analytics or controls. In blue, you see the analytics, and in orange, the controls, the advanced controls. There's a lot of exciting things going on in the industry and in the in industry and in academia about these topics. But today we're going to focusing on analytics and not on controls, just to give it an idea of what's the topic today. So most of us are familiar with legacy systems that we deal with. Back in the days, we had manual meters, and somebody had to write, the numbers down every month and go to a PC and then write this in Excel, and then we will store it in files, etc. Then after a few years, you got this wonderful meters that now send the information to a computer, and then finally to a wonderful a desktop application in this case. Then we have BMS systems and that have their own graphics and a computer that is probably from the 90s there. And then we have maybe multiple buildings, and we may have another BMS, which is great, although they're not compatible, not two different computers, and that's sort of a problem. We also have now new smart thermostats, which are usually pretty good, especially in more commercial buildings with rooftop units and such. So they don't use necessarily a local computer. They go to the cloud, and I can see information. I can change set points through my phone. That's great, although and this is a problem that everybody faces. These systems don't really talk to each other. So these systems are clearly siloed. They use proprietary software and protocols. There are multiple networks, so some of which use outdated protocols. They also have local SQL databases that may not be optimal to deal with large data sets. And they're fundamentally obsolete in terms of hardware. What we have now in the last few years is finally we have platforms that give us some kind of management of the data and visualization and analytics on top of this. This is great. So we have analytics on buildings that use some of these data sets and systems. Now we have maybe fault detection and diagnostic, which can look at some of the data, but not all of them. And the issue is now the two don't talk to each other. So we're back at this start. So I'm going to give you an example of how not having a central data warehouse may be a problem, and this is an implementation we had in one of my in the campuses I work with. So we have a lot of sources. You don't have to look at all of them, but there are meters and backnet controls and other systems, and those are sources. There's interfaces, which are usually software scripts or software tools running on local machines or remote machines that pull the data into databases. And as you can see here, we have both local databases. The Schneider Ion is one, and then we have additional databases. We use Lucid in this campus for meters data. We use SkySpark, but we also use another IT tool called InfluxDB and a Mongo database to do other things. So as you can see, the issue here is that these guys don't talk to each other. As you can see, meters data from Lucid, but not in SkySpark, and vice versa. We build applications on top of them, or we use the application they already use. So some of them use building business intelligence tools. We have apps. We have the apps for SkySpark, and we do quite a bit of research here at the lab, and so we write our own Python scripts. And the audiences are different. So there's facilities, there's researchers, and other things. So this may be a special case because we are researchers, but it's a frequent case that if you buy different applications, you get different databases. So the first lesson learned by looking at that is when you buy application and you think about your case in terms of FDD or whatever you want to do, you really have to think carefully about your data architecture because you're in charge of this and other people may not really understand your specific case. This is a simplification, but I think has all the components that you have to think about. There are data sources, and these data sources are the traditional ones that we saw before, but you can think of new ones. For example, there may be a website that gives you weather data. There may be access systems. There may be fire control and other things. There may be IoT devices. You may have additional wireless sensors that you want to integrate. So how do you do that? You use interfaces, which are also called drivers or connectors, that connect your sources through all the piping, meaning the local networks, through all the protocols and the other things to your database. A modern database has two components. It has a time series database component, which is an optimized database meant to deal with time series, which is much faster than older SQL databases, and a metadata database. We'll see what metadata means, but basically it's a description of your data. And you use that because both the inputs and the outputs of this database should be able to query the database and not just saying, okay, I'm going to link this point to this time series in the database. I want to be able, and you see query system on the right, to ask for example, all the temperature sensors in my database, or all the temperature sensors that are supplying air to this room. So this is an important feature which is not always present, but is very useful. You see APIs, which means application programming interface. Those are the interfaces of the database in and out. And you see different applications. So ideally, this is the framework we want. We want application to use the same consistent database, and the users use the application. And you see in red the user that goes back and actually does something. Otherwise, we don't save energy. This is an example that is another campus I've been working with. This is even more complicated. Quickly, you see meters on top. EMIS, building automation system, but we also have ALC and JCI. We have the Wi-Fi network that gives us occupancy data. We have smart thermostats. All of them live on top. EMIS also has a campus-wide computer sub-server, and we have additional databases, and then all the databases go to the bottom left, which has the data warehouse. And then we see, unfortunately, that data warehouse doesn't serve all the applications which are in bold, but actually goes to another database from the FTD tool that has its own thing. And then the thermostat had another database. And, you know, the morale here is just all these things don't talk to each other. In addition, one thing I want to stress out is that this representation shows the security architecture. As you know, facility managers don't usually think about this, but the IT people really care about how you implement this in the network. So you see there's different networks on top is the private BMS network. You see a demilitarized zone in the middle and the outside. So the application can't get directly to the building automation system network. Well, so this means that there are more concerns than the usual thing we think about. And this is a new framework we need to think about. There's not facility management anymore, but facility manager has to relate with IT because they have the expertise and they are usually in charge of the security. So these are some of the tasks and responsibilities that two groups have. You know, facility managers usually do quality control, data analysis. They may develop their own apps and analysis tools. They may actually implement work order or adjust control system or do commissioning, while the IT would take care of the network architecture, so you don't have to, you know, worry about all the piping and the connection between things, security, privacy, etc. So this is important because this was not the case in the past. You have, you know, private networks, and you have if you're a facility manager, you're in charge of that. Now it's a new era, and we really need to involve our IT. Going forward, this is my personal experience in the pain of developing this and all the complaints that I myself, you know, kind of find into. So at the beginning, it's all data is all over the place. I can't quite understand anything. It's so bad, I'm going to cry. And then we put in place a central data architecture. We're all good, right? No. Now I don't understand what the data means because the data is not tagged. There's a lot of IDs that don't mean anything. That's completely incomprehensible. Then I spend time and assign the metadata to the system. So I describe the data carefully. And then no, the data quality is terrible now. All the data is missing, and you know something is wrong. I don't know what it is, and I still cry. And then I do some work to establish procedures to clean the data and the process to clean the data. And now the new problem is there's really too much data. I mean, now the data is clean, but I will never have time to look at it. So we developed aggregated analytics for the whole campus, and now we're finally happy, but no, because nobody actually does anything. So I know exactly what's wrong, but nobody is doing anything. And so the final step is actually doing something about it and putting in place some process to actually go fix the things. And so I'm finally happy. So going briefly through them one by one, the metadata is essential. So for people who don't know what the metadata is a description of the building system. So for example, the sensor names is part of the metadata, but also the relationship between sensor points. So this sensor is a VAV point that is served by this air handling unit, which is served by this chiller, is one of this kind. This information is usually stored not just in the point name, but also in graphics from the BMS and other tables and storage systems. Typically, this is set up by technicians by hand, so it's error-prone and very inconsistent. So this is an example of one of the buildings. You can see I searched for CCO, which is the cooling coil valve, and I got all the stuff that is not what I meant. So there's a max, there's a CCO max, there's a VAV point, and other stuff. So we can do much better than that. You know, any convention is better than no convention. Obviously, there's emerging conventions that are probably better. This is Haystack, and I know that Stephen is going to talk about this in a minute in more details, but this is an example of how you can simplify this tagging, this data point with tags, and also giving references to the air handling unit it belongs to and the building. The second lesson learned is data cleaning. This is an important step. It's not just that you need to clean the data at the end. You really need to identify where the problems are. This is a table with some examples about the meters, and you can read about it. But it's basically, there's different points where the data can break, and you really need to make sure that all are addressed. The second point I want to make here is that when you have the data and it goes to the DB, then you may want to clean it, you need the system to feed the data back to the system. And currently, databases don't really have version controls, so this is a challenge also for today. Now, how to aggregate the data, and I said, you know, aggregating is necessary because I have a lot of points. Everybody likes, you know, pretty graphs. This is great. It tells me a story. But if I have 1,000 of those, I don't probably want to see them all. So how do I summarize them? Do I do an average? Do I, you know, summarize by year, by number, by code, by building? That's a, you know, critical question, and you're the best person to answer that. The last point I want to make here, which is very important, is the closing the loop. So you're the analyst. You're probably here because you're interested in figuring out the architecture. But you have to think if you have control of the next step. And one thing I've seen in my experience is that you get to a point where you're very good at getting all the issues, but then your organization have to be able to absorb your inputs and actually act on them. Okay, so this was it, and I want to thank all the people that work with me on this, and that's it. Thank you.
Thank you so much, Marco. Boy, I'm so impressed how quickly you got through all that. That was a lot of great content, and yeah, I'm sure we'll get some good questions from that. So just a quick note to everybody, if you have any questions, we will have some Q&A after the next presentation to cover any questions on Marco's presentation or the upcoming one. Just submit them to all co-presenters via the chat function. Another thing just to note as well is that toward the end of the presentation today, we'll have a poll. We're really interested in this topic broadly. It's big. We're not going to cover everything, I'm sure, today. So we'd love to get your feedback at the end of today's webinar, just other topics you'd be interested in around the general topic of data management, or anything you've seen today that you'd like to do a deeper dive on. We'd love to hear from you, because I think there's a lot to explore here. But with that, I will ask Dylan and Stephen to go ahead and pull up their presentation as I introduce them. So Dr. Stephen M. Frank is a Senior Systems Engineer in the Buildings and Thermal Sciences Center at NREL. Steve leads the innovative research at the intersection between buildings, renewable generation, and the electric grid. His active projects include the deployment of NREL's next-generation campus energy information system, and the development of advanced model-based fault detection and diagnostic software for commercial buildings. Dylan Cutler is one of the technical leads on the Intelligent Campus team, which is focusing on NREL's own control system integration and energy informatics in infrastructure. He also has worked with a number of federal agencies as they deploy their own energy management and information systems. Dylan also has led a number of technology demonstration efforts, performing on-site testing and analysis to confirm technology performance claims. Over to you.
Thanks very much, Elliot. Yeah, that's the group here at NREL, Dylan and Steve, and
that's Dylan, by the way. I'm Steve.
Yeah, Dylan talking. And we work together on the Intelligent Campus project, and we're gonna just kind of walk through this as a bit of a case study while touching on some key considerations of the EMIS deployment that we face here at the lab. So just a quick overview of the NREL campus for those that aren't familiar with it. It's a national lab here in Golden, Colorado, a little over 1 million gross square feet of building space, 2,000 employees plus. The current EUI is about 120 kBTU per gross square foot, and that's dropped significantly from our baseline in 2003. So over the last 15 years, made a lot of efficiency improvements and added some high performance buildings. That's one of the reasons that's driven us to focus more on the EMIS and kind of fault detection applications is to continue to be able to drive down that EUI. And we also have a fair amount of solar PV on site, so a number of different systems that we're trying to integrate.
So as Dylan just mentioned, as we get more complicated buildings, greater targets for energy savings and lower EUIs, we end up with a lot of systems that need to be watched carefully to make sure they're operating properly. And so this has really driven us toward looking at analytics as a way to do that. So as part of that process, we've been working on revamping the NREL Energy Management Integration System. And to just kind of give you a snapshot of where we're at, we began about 4 years ago with establishing, okay, what are our goals for the update? And then we went through a pilot phase where we looked at some different products. Beginning in the third year, we focused on kind of implementing the infrastructure, and then we started bringing in buildings and really expanding across campus this year. So even though you see here we've got 22 facilities, of which we have data for most of them, but only complete data for 3, this represents kind of a lot of work to get to this point, but it does get easier as you go along. So far we have about 16,000 data points on our way to probably around 50,000. We have all those different kinds of systems that Marco mentioned, our electricity meters, our building automation system. We have other kinds of esoteric meters. We have electric vehicles and weather station and forecasts. And we're trying to manage all of those data, bring them together in one place, which brings us to kind of the lessons that we've learned along the way. So we want to share with you 4 quick lessons that will parallel pretty closely some of the stuff that Marco was saying. So kind of our lesson number 1 is establish your goals, know where you're headed. Because if you don't know where you're headed, where you're trying to get to with your energy management information system, it's going to be hard to make a plan to get there. So what we've seen a lot of, and what we have in fact done at NREL in the past, is just to say, you know what, we're not really sure what we're going to do with the data. We're going to collect all the data, and then we're going to see what we can do with it. Don't do that. We've been there. We've done that. We kind of went through that phase about a decade ago here at NREL and ended up with a massive amount of data that was unorganized and nobody knew what to do with it, and we had no goals for it. So instead of doing that, what you need to do is figure out where you want to head and how you're going to get there.
Okay, so Dylan, taking back over on some of the questions that we found useful here as we kind of embarked on this more recent effort. And the first one is really, what do you expect to gain from this EMIS? There's a bunch of different kind of value streams, benefits you could hope to achieve. everywhere from kind of just benchmarking, how are we doing relative to others in my own other buildings in my own portfolio, across a large portfolio. Maybe it's really focused on some detailed FDD, fault detection and diagnostics. Do you want to engage your tenants? Do you want to be focused on research? So there's a lot to kind of figure out as far as your goals. And then it comes down to, all right, I'm gonna have these expectations from my EMIS. What types of systems do I need to include? There's some examples there. And then the last one is really important. I think Marco hit on this, but who's going to use this information? Do you have a plan in place to have, people with time to understand, all of this information? And then do you have the policies and kind of infrastructure in place to take action? Because that can kind of be that closing of the loop is really critical, and something we've struggled with and are starting to kind of put some policies in place to really get through that stage. So these were some of the goals that we had, pretty diverse. So everywhere from kind of situational awareness for some of the site operations folks, engagement of our staff here, a big goal on fault detection, actually improving operation of our buildings and continuing to drive down that EUI, demand management, some kind of more researchy applications, using kind of combined PV and storage to reduce demand charges for our facilities, and enhancing the research. There's kind of that maybe is a slightly different goal that we have. And then also we had a lot of people come through the lab and wanted to be able to kind of have some information about what we are currently doing and kind of expose some of this analysis and research to those passing through the lab. So that's kind of what was driving us. This is kind of interesting. I feel like this is the third time you've seen this graphic during this presentation, once a bit from Elliot, once from Marco, and once here, and it's in some ways kind of reinforcing the fact that there is kind of a common architecture that folks are kind of settling on, and I think why it's important to look at it this way is because on that last slide you saw 6 kind of goals for EMIS that are very distinct in some ways. And especially if you went out to industry and told them that you wanted to meet those 6 goals, you might get 6 different applications back. But if it's correctly architected underneath the hood, they can all leverage kind of a common data infrastructure, and that's really what we're trying to speak to today. So I don't think there's too much more that we need to add here, except that this was really important for us in defining requirements around kind of a procurement approach to getting some of this in place, really understanding each components of these stacks, this stack and the architecture. So this is kind of the lesson 2 that we had, which is really assemble your team early. This is critical to the success of moving a whole EMIS into implementation. These are some of the folks that have been critical to our team, going from energy analysts and energy managers, facility managers and operators, and Marco touched on this as well, the cybersecurity and the networking and IT folks. These are all really important players to both understand how things are actually operating in the buildings, what are their needs as far as improving operation, that's more on the facility manager side, and then actual implementation of getting the servers in the right place with the right firewall exceptions. A lot of these control systems operate on slightly different networks than our kind of internal networks or definitely the external kind of internet. And so getting the right people, the right access at the right points in a cyber secure manner is important. So this is kind of the benefits that we see of a team approach. Really it starts with just understanding, who owns the data, how do you kind of get access to it, what are the requirements, like I was saying on the cybersecurity, and then on operational requirements, what is the whole picture, not just the one use case you think is really important as kind of maybe the energy manager, as the person kind of driving this implementation. And that ensures kind of buy-in from top to bottom, gets you the funding you need, hopefully, to lined up to support using this infrastructure in the future. It also, we saw, places where as we went through procurement, if we hadn't kind of understood some of the cybersecurity and hardware requirements that our IT staff was placing on this, we might have ended up buying things that wouldn't eventually fit with their whole infrastructure. This is just kind of one last example. As Steve mentioned, we kind of went through this pilot phase, and I don't know that everyone needs to do that. This was partially research driven and partially let's figure out the best thing for our campus, because we had kind of gone down some paths that didn't work out in the past. And so these were a bunch of different pilots that we were trying to put together. And to understand this networking diagram, where to place these different pieces of software and how to get data access for them, this took a lot of different people from across the lab, folks from 4 different directorates, from site ops to research to the cyber and networking team. So challenging to pull this together initially.
All right, lesson number 3, organize your data. So I believe this was step 2 on Marco's stages of data integration grief. And I think it is very important. What we found is that if you don't have a strategy for organizing your data, you will not be able to make your EMIS efficient and scalable. So you'll be kind of stuck in just cleaning up and figuring out what's what in perpetuity. So this is pretty important. The way that I like to think about this is in terms of the data, information, knowledge, wisdom pyramid, which you may or may not have seen. But the idea here is that you cannot go straight from having data to having wisdom or insight about what to do with your system. You have to get through these other stages. So you have to get from data to information, which is basically data that makes some kind of sense, and you use that with analytics to get to knowledge, and then you have insight. So to get to information from data, you need what's called metadata. And what is metadata? Well, basically metadata is data about your data. It's describing what it is that you have. So it's things like, is this a temperature sensor? Is this in Celsius or Fahrenheit? Where is this temperature sensor? What exactly is it measuring? Water, air, blah, blah, blah. So you need all this information so that both you as the operator can understand what you're looking at, and you have communication between 2 different pieces of software. The pieces of software need to understand what they're looking at. So one of the ways to think about this is in terms of interoperability. And there are kind of multiple pillars of interoperability that you must achieve to have a successful system, starting on the left with technical, which is basically does software A talk to software B, and on the right-hand side, it's organizational, which is, do I have the policies and procedures to actually do something with the insight I'm gaining? But what I want to talk about is in the middle, the informational interoperability. And there's a bunch of different things, but we have closed in here at NREL around a standard called Project Haystack, which Marco also mentioned. And the reason that we've done this is because we think it's both flexible and extensible, and allows us to kind of get where we are trying to go. So I wanted to give you just a little flavor of Project Haystack, the way that it works and kind of what it can do for you. So Haystack is a pretty simple structure. You have, for any given data stream, you have, or entity actually, you have a bunch of name-value pairs, which they call tags. And these tags describe what you're looking at. So the basic hierarchy is you have sites, you have equipment that are within those sites, and you have points. And then within this structure, you have different kinds of tags that describe these different things. So you have every entity gets a unique identifier, and this allows you to reference it. And then you can map relationships between things by mapping these unique identifiers together. So if I have one building, I'm sitting in a building called the Research Support Facility here at NREL. I can tag all the pieces of equipment that are inside that building, and I can point them back to the main building. That allows me to find things later. The third kind of tagging that you have in Haystack is just information that's describing the characteristics of an object or a data stream. So in this case, this point is an energy sensor, and it's on an electrical meter. So that electrical meter in the middle, now I have a way to understand what it is I'm looking at and what the units are and critical information about it. So we've gone the route of putting Project Haystack tags on all of our data across all of the different data streams that we pull in, and this really has let us do much more efficient analytics. One thing that I also want to mention here is that whatever metadata schema you choose, which may or may not be Project Haystack, but what you choose should support your analytics goals, and if it doesn't quite, then you need to figure out how to make it do that. And just as a quick example, in our case, we wanted to do analytics that didn't just look at pieces of equipment, but looked at entire spaces, particularly laboratories. And so we added something to the Haystack hierarchy. We added this space entity that we inserted between site and equipment. So you can do this. But without knowing where you're trying to get, you won't know kind of how your data has to be organized. And then finally, last lesson, no additional slides here. Don't panic. It does get easier. It's quite difficult in the beginning when you're setting it up in EMIS to figure out what all the pieces need to be, how they plug together, what your network is going to look like, what your requirements are, blah, blah, blah. But fortunately, once you get into it, if you've taken the time to think through things ahead of time, have an organization scheme, have a strategy, then it does get easier. So the last building that we pulled in, which is the one I'm sitting in, Research Support Facility, is our flagship net zero energy building. It has something like 5,000 different data points that we wanted to pull in, and it took a total of maybe 40 hours to do this building, whereas it took us hundreds and hundreds of hours to set up the infrastructure previously. So you will get there as long as you persevere. All right, that's it for us.
Okay, well, thank you so much. I have to confess, I've never been more worried about how long presenters are going to take than I was for today. But you all did a fantastic job getting through a lot of material, and we have some great questions coming in as well. Please keep the questions coming. The sooner you get them in, the more chance you have to get them answered. And I'm sure you're all waiting to find out about our LinkedIn group recruitment drive, and we're up to 43 members now. That's 9 new members today. Check the chat for the link to join in. Oh, we got another one. So I'm going to jump into the questions here without further ado. So just the last piece there, you talked about Project Haystack, Steve, Dylan. But I think you'd also mentioned Brick. What was your process for deciding on Haystack versus Brick? Do you have any thoughts on how they contrast with each other? Of course, we don't endorse any products, but I'm curious, what was your process there and how you made your decision?
Well, in our case, it's pretty simple. Brick didn't exist when we started this. So Haystack was the best option available 3-4 years ago. When we started. That said, I think the primary reason we went with that we would go with Haystack now is that there's a lot more industry uptake and a lot more commercial product around it. Brick has some really nice features in terms of the standardization of the way that things are mapped together, and potentially more complete coverage. But there aren't any products supporting it yet. I think I should mention there's been a lot of conversation between folks on the two standards, and there's some effort to kind of harmonize them or translate between them.
And the ASHRAE.
And also the upcoming ASHRAE work with updating the metadata standards for BACnet. Yeah.
Great. Thank you.
This is Marco. So I work with Gabe Fierro, who's one of the people in the Brick team. They're really talking now in the ASHRAE committee to kind of try to get to a single unique way of having the simplicity of Haystack and the depth of Brick, but it's a challenge. And also, Brick is very new. It's been mostly an academic exercise until now, And so, yeah, it's true there's no current system working with that, but I wouldn't be surprised that whatever new iteration comes out will be adopted by several companies. I know Google is interested, and other big guys are interested because it uses a more familiar way of organizing data for web applications, and so. But yeah, I don't think if you choose Haystack, you're not gonna lose, I guess. And if they find a way of merging everything good together, you're probably gonna be fine.
Great, thank you. And on a related note, are there any kind of significant gaps in those schemas in terms of systems that aren't yet included, or renewables, or any experiences around that?
Yeah. I think at least in Project Haystack, it's kind of a community effort to add systems, and it's getting pretty complete for a lot of the standard building systems, but they're always adding more. And I think one of the nice aspects, at least with the Haystack standard, is it's completely extensible. You can add a tag that fits your organization's need, or a set of tags to describe, like in this building, we have a lot of radiant systems that aren't fully worked out in Haystack, and so we're working on that, and we'll hope to contribute back to the community as we kind of find stuff that works. But for right now, we can extend that in our own project somewhat on an ad hoc basis.
I do think everybody's also struggling with how to incorporate geometry into a standard so that you can do a spatial querying or kind of spatial hierarchies, rooms within floors, within buildings, within campuses, and all their geographic coordinates. Everybody's still working on that. Nobody has it figured out yet.
Okay, thanks. And again, sticking on similar subject, I think conceptually, I kind of get how Haystack or Brick would work, but what does the actual work look like? In actually doing that, is it someone at a console just working long nights, just pouring through screens to tag things? What is the level of automation and support that you've had in getting to the final point?
It's a very interesting question, and it really depends on how organized the original system is. So in some cases, there's virtually no organization, and in other cases, it's fairly well done. So in our case, we have every building seems to have its own standard for how things were named and how panels were organized in terms of the building automation system. And then we have a half dozen different meter models that are Modbus meters, so we have to know what the register maps are for those. So for any given meter type or any given building, we have to do the hard work of sitting down, figuring out what was the naming convention, and then after that, it becomes easier because you can kind of tag everything with the same name using the same Haystack tags and start to standardize across your buildings. But it certainly is a lot of digging to start with.
Yeah, I think the list of tagging is not to be kind of underestimated. One approach that's proved valuable for us is to kind of try to find like example equipment types, do one or two in detail and understand what's required to get back to that goals thing. What do we need? What points do we need? And what level of tagging do we need? And then automate that across the building as best as possible with some scripting.
This is Marco. I agree with them. In one of the two campuses I've worked with, I'm not going to say which one, the naming was very consistent. There was basically a single person naming all the points, and though he's a human, you can see the consistency. And so breaking down those names into tags and making sense of it was kind of simple. In the other case, we had multiple BMS. The worst case was also the multiple BMS in the same building with different conventions for each system. It was just a disaster, and that was much harder to actually kind of tackle. So it depends. In terms of research and automation, I think this is a really hot topic in research. There's several projects that are trying to use machine learning to minimize the effort required by people, but obviously if you have no standard and names are just random strings, that you're not going to be very successful.
Thanks, Marco. But we had another question come in here again on the same topic. I'm going to paraphrase it here. So once you've used Brick or Haystack or whatever else you might want to use as a schema to get the tagging how you want it, could you maybe articulate how that actually helps you automate the application of analytics? Maybe I'll direct that to Marco first. What is it that actually makes the tagging special or beneficial when it comes to using that data?
So what computer scientists taught us is abstraction, which is very hard for a mechanical engineer like me. But basically being able to not hard code everything and say, this is specific to this point, but run a query that says, give me this type of template of air handling unit, and for each air handling unit, apply this rule, is a game changer, because it takes away all the manual stuff that is error prone because you're human, and it's not repeatable. So having this way of classifying things that can be queried allows you to go away from the specific case and write rules that are more general.
Thanks, Marco.
Yeah, and then maybe to add just one quick example from our experiences for one of our labs, the Energy Systems Integration Facility here at NREL, we wanted to look at exhaust flow out of these laboratory spaces. And essentially we were able, like Marco was saying, to use the tagging to understand, to kind of combine all of these different exhaust valves into one metric that calculated CFM per square foot. And essentially there's some standards for lab exhaust that 1 CFM per square foot, depending on the hazard type, that was what was required. And so we could write one rule that quickly combined a whole bunch of different sensor points, calculated that, and then we could see exhaust for all of the labs in the building. And so you're quickly able to see if you're under that 1 CFM per square foot, you may be in a safety consideration. That's critical for us to understand. And if you're over it, you're over ventilating the space, and you may be able to save energy. So like really valuable insight for our building operator and safety team, but basically built all on one short rule once the tagging's done.
Yeah, and if I can comment maybe specifically on how the tags worked in that case. Well, we have one set of tags that labels exhaust valves. I think it's exhaust and valve, actually. And so you can very easily pull up all the exhaust valves just by querying on those terms. And then because of the referencing, we can reference those exhaust valves to the laboratory spaces, each of which is uniquely identified. And then each laboratory space has its floor area tagged to it. So within just the tagging, we've been able to identify all these exhaust valves, match each one to a space, and then within that space, we've been able to divide the total flow by the floor area just by leveraging information that's all embedded in our database without any external data that has to come in manually. Thanks.
Yeah, great answers. I was actually going to ask for an example, and there you go. You just jumped right in there. So in both presentations, I think you both kind of spoke to this idea that you're presenting as national labs. A lot of research goes on, and that there may be some things that you've gone to that perhaps serve a research need that many others don't have. And I'm curious. We deal with owners who perhaps own a large portfolio or a large campus, and they'd like to sort of dip their toe in the waters with this kind of work and perhaps just try one building or a small amount of buildings. Would you have any advice for anyone out there who's interested in taking this on but perhaps doesn't have the resources to really take the full leap forward into the full solutions that you were both presenting on? And I'll direct that to NREL first.
Well, one of the things that we ended up doing here, which again, I don't know if this is the right answer for everybody, but we said, well, we don't really know what the big picture is going to look like, so we're going to set out our goals, and then we're going to try out 2 or 3 products on a small scale with some of our smaller buildings and see if those products seem to be getting us toward our goals. So if you were doing this for a large portfolio, you may want to run a pilot where you're just doing 1 or 2 buildings, and then use the lessons learned out of that pilot to adjust your specifications, adjust your approach before you do it for a broader set of buildings. But I do think that the important step of sitting down at the beginning and saying, well, what am I trying to achieve? Do I need to do controls or no? Am I looking at detailed building automation data, or can I get by with just my electricity meters or my natural gas meters? Asking those questions about what you're trying to achieve will help up front to identify what kinds of systems you need to pull in and what kind of effort you need to make. So that is an important first step. Those might change after, over time, but having an idea of where you're trying to get to is critical at the beginning.
Thanks. And same question to Marco. Any advice?
Yeah, so I agree with them. Start small and try to close the loop as soon as possible. So don't get fancy on the analytics as we do, because we have like students who want to really answer questions and do research, and try to get something done that actually brings value to what you're doing, by identifying faults and rather than just try to get all the data in a spot right away, which may take a year, because that is going to reinforce your position in the organization. You're going to be able to say, well, this is actually working, etc. So be very concrete and small steps, I would suggest.
Thanks, Marco. We have about 8 minutes left. What I'm going to do is pull up a poll here for all the attendees. We're not trying to get rid of you yet. I'm going to keep going through these questions, but as I said earlier on, we're really interested to hear from you if you want to dive deeper in any of these specific topics we've covered today, or anything else related specifically to the data management topic. We'll continue providing outreach on all things EMIS around analytics and savings and all sorts of topics, but just on data management, we'd be interested to get your feedback. So I'm going to put this poll up. I'll keep it up for the next 5 minutes or so, and maybe some ideas will come to you along the way. And but just following on here, the idea of a pilot, really thinking about working with third-party providers. I'm curious if we can hear from the presenters on your experiences working with third parties. You both presented fairly complex, broad solutions that involve hardware and software and analytics and all kinds of things here. How's been your experience working with third parties in terms of them understanding your needs, understanding how all the pieces fit together, if you need to really deal with several specialists to take on different elements of the data management task, or if you can find someone that does it all? And just curious your general impressions and maybe even how that's changed over time. I'll maybe ask that to Enrel first.
Yeah, we were just having a kind of chatting about our own experience. It is somewhat complicated in that as a national laboratory, we have some rather unique needs, so it's hard to find a service provider that meets exactly all the needs of our laboratory. But one thing we found, I'd say 2 things that we found. First of all, there are folks that deploy fault detection diagnostics or energy management information systems for a living. They have deep knowledge, and you should absolutely go talk to them and leverage that knowledge, right? But the second and equally important lesson is that you cannot solely rely on somebody outside your organization to do it for you, because they will not have a full understanding of your unique goals and needs and the capabilities that the system needs to provide. So you also need kind of an internal champion, somebody who is going to be in charge of the EMIS for your organization. Even if most of the work they're delegating outside, you need that internal person to be the point person. Our experience working with outside organizations has been pretty good when we can provide that guidance. So we've leveraged outside organizations to set up meters. We've leveraged them to look at our network for us, and also to implement a lot of the tagging. And for the tagging in particular, we kind of laid out what our expectations were up front with them, and then let them go do it. And because we had an idea of where we wanted to go with the tagging, they were able to do it pretty efficiently.
Thanks. And Marco, do you have anything you'd like to add to that?
So I've seen different models. For example, in different campuses in California, different campuses use either heavily third parties and they have a minimum crew in, or the other way around. And they both work. I think the advantage of doing things with a lot of inside resources is that knowledge doesn't go away. It stays in the company and you can kind of plan and develop, but you also have to have access to that. And it's more rigid as a type of a system than relying on third parties. The issue with third parties is that you have to build trust. And what's happening now with smart building technologies, you have 100 people knocking on your door and saying they have the new product that is going to fix all your issues, and people are starting kind of being skeptical. And maybe there's some great solutions out there. I'm one of the 100 people there, but you really have to have some knowledge or rely on somebody who can, judge which you really need and which you don't, and that's challenging. So I think the fact that so many things is actually now working against the system in a sense.
Okay. Thanks very much, Marco. I think we've got time for perhaps one more question, but before I ask it, we've had a few questions more generally about EMIS, about the costs and benefits and specific ways that metadata is used. Now, since today's webinar was specifically focused on the data management topic, I don't want to get too deep into the broader questions there, but what I'm going to do is just send out a link via the chat function to some resources that we have developed for the Smart Energy Analytics campaign that speak directly to that topic. And within the website, there are some past webinars that talk a bit more about that more broad application of EMIS, and I'm sure it will come up again. So I'd direct you to that as I just asked the last question here on the data management. So we talked a lot about the sort of hardware and communications infrastructure. We've got the analytics applications at the user end of things, but there are other products, the sort of middleware, you might call it, data management software that is really primarily focused on getting the data in one place, and then your analytics apps plug into that data management software. I just wonder if you have experience with those kind of softwares and what your impressions are and how they fit into the big picture. I'll ask that to maybe Steve or Dylan first.
Oh, okay. We were thinking you were going to ask Marco first.
Okay, I'll ask Marco first. First. Go ahead, Marco.
So it is, I have experience with one software which is like a traditional data warehouse that gets all the data, which is used in one of the campuses I have been working with, which works fine. This is especially useful if you want to write your own applications or if you want to develop your own things, so for more like custom systems. There's also, and I want to mention this briefly here, a lot of new data warehouse systems that are very efficient databases that are coming from the IT industry. So these are the things that have been used for network monitoring or other systems. And those are typically fairly light software packages that are open source and simple to use for the IT folks. However, they do not have drivers, so you still have, need somebody to push the data or pull the data, depending on what you want to do, to the database. And so this is another custom kind of implementation. If you only have, a specific application, and it's probably easier to just buy whatever software that does that for you, but you want to make sure that this software has a way of coordinating with other applications. You want to connect to it through APIs.
Yeah, so I would echo a couple of the observations from Marco. There are lots of ways to do this, right? There are solutions like the OPC architecture that's just a translation layer so that everybody gets everybody in the same communication protocol. There are distributed solutions like the Niagara JACE solution where it does the translation at the endpoints. There are companies that will aggregate all your data and send it to the cloud. And then there are companies that will aggregate all your data and kind of put it in a local database. The two observations I want to make, or I guess three actually. One is figure out what's going to work for your IT and cybersecurity requirements, because that might eliminate a huge part of the field. Number two is strongly consider a commercial solution over stuff that you write yourself whenever possible, because there's really a lot of ongoing time investment and cost in supporting your own homegrown solution, and people really often underestimate that. We made that mistake here at NREL, and it cost us a lot of money before we fixed it. And number three is basically that whatever approach that you take, you need to know. I'm trying to figure out what the best way to put this is. You need to have a strategy for what all the different pieces are, and often you're going to have a balance between something that's really familiar to information technology folks and something that's really familiar to facilities folks, and probably you don't want to be on either end of that spectrum. You want to be somewhere in the middle, so that it's good for both worlds.
Wonderful. Well, thank you all so much. This has been one of my favorite webinars I think we've presented here. So thanks to Marco, to Steve, to Dylan. Thanks to Guanjing and Hannah, Claire, Jessica, and the rest of the team here at LBN Alpha helping presenting this. And we hope to see you all very soon. Thanks very much.